Welcome everyone. I'm Mohammad Farooq Siddiqui and today we are diving into how email authentication works using SPF, DKIM and DMARC. These are the three tools that help protect your email domain from hackers, spammers and impersonators. I'll explain it using real-world examples. Let's get started. So, what is email authentication? Think of email authentication like checking someone's ID before letting them into a secure building. It verifies whether the email really came from the sender it claims. It's a way for the email system to check, are you really who you say you are? Did you tamper with the message? Should I trust you? Without authentication, attackers can easily pretend to be someone else. Authentication protects users, prevents phishing, and builds trust with mailbox providers like Gmail and Outlook. There are three main technologies involved in email authentication: SPF, DKIM, and DMARC. Each plays a different role, but they work together to validate emails. They rely on public DNS records, like posting rules on a public notice board. So any receiver server can check them before accepting an email. SPF works like a guest list. You declare in DNS which servers are allowed to send emails for your domain. When a mail server receives your email, it checks whether the sending IP matches the allowed list. If it's authorized, SPF passes. If not, SPF fails. Remember though, SPF only checks the sending server, it doesn't protect the email content. While SPF is a powerful tool for email authentication, it has several important limitations. First, SPF has a strict limit of 10 DNS lookups per check. If your SPF record has too many includes mechanisms and the total DNS lookups exceeds 10, your SPF automatically fails. Second, email forwarding breaks SPF. When someone forwards your email, the forwarded server's IP is not in your SPF list, causing SPF to fail even for legitimate forwarded emails. Manual forwarding doesn't break SPF because you are sending a new email. Automatic server-side forwarding breaks SPF because the server relays the original message without being authorized by the original domain. Third, SPF only validates the sending server's IP address, not the actual content or subject of the email. If you whitelist a huge IP range like all of Azure's IP space, you are trusting thousands of servers you don't control. A cyber criminal could set up a server inside Azure, spoof your domain, and SPF would pass because the IP falls inside the allowed range. This is why you should always whitelist only the specific IPs you control, not entire data centers. Also, SPF records have size limits, around 255 characters per string. If your SPF grows too large, it can break silently, causing random delivery issues without warnings. To avoid the DNS lookup limit, we use SPF flattening. Flattening replaces all your includes and MS lookups with direct IP addresses, eliminating the need for DNS lookups during email checks. This keeps SPF efficient and avoids hidden failures. But one thing to remember, if you flatten manually, you must update it regularly because provider IPs can change. Flatten your SPF records carefully and keep them updated because a broken SPF can make even legitimate emails disappear. DKIM acts like a wax seal on your email. It adds a cryptographic signature to outgoing messages, proving they haven't been tampered with and validating the sender's domain. Receiving servers verify this signature using the public DKIM key stored in your DNS. Even if SPF fails, for example during email forwarding, DKIM can still pass and protect the email. DMARC ties SPF and DKIM together and defines how the receiver should handle failures. It can tell receiving servers, just monitor failures, send suspicious emails to spam, or outright block fake emails. DMARC also gives you visibility into who is sending emails on behalf of your domain by sending you daily aggregate reports. DMARC tells the receiver what to do if an email fails SPF or DKIM. Should it be quarantined, rejected, just reported? It also provides reporting as you can monitor attempted abuse. There are two types of DMARC reports, RUA and RUF. RUA reports are daily reports. It's a summary about all the emails, pass, fail results grouped by domain IPs. And RUF are detailed copy of individual failed emails. So RUAs are sent once a day and RUF is sent whenever an email fails. So we will use two of my domains as real world examples. So let's say upwork.com sends a message to mfsid.com. It checks SPF, DKIM and applies DMARC policy. So mfsid.com checks SPF, DKIM and DMARC of Upwork by querying DNS of Upwork. So it will check the SPF to see if the email that is sent, the IP of that server is in the allowed servers in the SPF record of Upwork.com. It will then check DKIM record and then it will then check DMARC policy to see if that email should be accepted or rejected. If either SPF or DKIM passes with alignment, the email is delivered. If both fails, DMARC's reject policy will block the email and the sender will receive a bounce message notifying them. If the DMARC policy is set to quarantine instead of reject, then the email will be sent to the recipient's spam emails. We have already discussed this, so let's move forward. So to wrap up, so that is how SPF, DKIM and DMARC work together like security guards for email. They protect your identity, your brand and your users. But they must be set up carefully. SPF must be monitored and managed, DKIM must be signed properly, and DMARC must be rolled out in stages. You can reach out to me for help setting up email authentication for your domain. If you found this helpful, hit the like button, subscribe for more tech explainers, and comment if you have any questions. See you next time.